In this section, we'll look at the components of a blockchain. We'll go through each component in detail, talk about how it works, and how it contributes to the overall functioning of the blockchain network. Let's start with the ledger. So the ledger contains a blockchain of invoked transactions, and it also contains a state known as world state. World state is simply a collection of variables that reflect the results of the previously invoked transactions. So at any given point in time, world state reflects the state of the ledger after all the transactions up to that point in time have been invoked. Now let's look at smart contracts. Smart contracts are application level code that's stored on the ledger as part of transactions. So we can say that smart contracts run transactions that may modify the world state of the ledger. Smart contracts are extremely useful because they allow the participants in the network to agree to certain rules that govern their interactions that result in transactions being written to the ledger. So for example, consider a smart contract that governs the transfer of assets between two parties. The state of the asset could be stored in world state in one or more variables, and then the smart contract code could consult those variables prior to recording the asset transfer in the ledger to make sure that the transferring party actually has permission to make the transfer at that point in time, and the receiving party actually has permission to receive it. So it allows you to put application level code in the ledger rather than just recording transactions and having all the application logic in the applications that are running outside the blockchain. So let's talk about consensus networks. So a blockchain network is a distributed, decentralized system, and this provides many advantages, but one of the challenges in such a system is to maintain consistent state. An obvious example would be the world state of the ledger, right? This is something that needs to be consistent in order for the network to function properly. So the way that's done in a blockchain network is via this idea of a consensus mechanism, which is based on different algorithms that can be plugged in. And while they all work differently, conceptually they all work the same. So we're using consensus as a reliable proxy for the world state of the ledger. And in order to understand how this works, it's probably useful to look at an example. So let's look at a really trivial example. You are a new employee, first day on the job, your boss is on vacation and has left instructions with your teammates as to what your first task should be. So in the first scenario, your team size is 3, you have 2 other teammates. One tells you that the boss said to do X, the other one tells you that your boss said to do Y. Well, in that scenario, it's very difficult for you to know what your boss really wanted you to do. And let's assume, for the sake of simplicity, that one of those choices does actually reflect what the boss wanted you to do. And again, it's very hard to know because you have one person telling you one thing, somebody else telling you something else. Now let's look at the same scenario, but now you're on a team of 50. And now 48 people are telling you that the boss told you to do X, and only one person is telling you that the boss told you to do Y. So you can see in this scenario it's very different, right? Because you can recognize immediately that the probability that 48 out of 50 people are either bad actors or have made honest mistakes is very low compared to the probability that just one person is a bad actor or has made an honest mistake. And that's basically how these consensus algorithms work. They depend on the fact that it would be very difficult to compromise a viable majority of the nodes in the network. If a viable majority of the nodes in the network agree in a certain state, the probability of that being the world state is very high. So just to summarize, the consensus network maintains a consistent state throughout the network. Now let's look at the membership component. The membership component manages the various certificates that are used within the network. These include identity certificates, which are used to make sure that participants are actually who they say they are. And there are also transaction level certificates, which we'll discuss in a later module, that are used at the transaction level. The membership component also manages other aspects like permissioned access and confidentiality. So making sure that various participants in the network only have access to the parts of the network and to the parts of the ledger that relate directly to what they're doing in the network. Next, let's look at events. Various events are generated during the operation of the network. For example, when a new block is added to the blockchain or when a smart contract is invoked. Notifications for these events will be generated by the event component. Next, let's look at systems management. This component provides the ability to create, monitor, and manage the various other components within the blockchain. So whether it's actually bootstrapping a blockchain network for the first time, to tweaking a blockchain network, adding additional smart contracts, and so on. This is all done by the systems management component. Next, there's the wallet. The wallet component securely manages a user's security credentials. And then finally, there's the systems integration component. This component is responsible for integrating blockchain bidirectionally with external systems. It's technically not part of the blockchain, but is used by it. So chain code can use this component to call out to existing systems, and existing systems can use this component to call in to the blockchain itself to do things like invoke a smart contract, for example. So those were the major blockchain components. In subsequent modules, we'll go into more detail about the various components and how they operate.